Welcome to today's Explainer. We're going to dive right under the hood and demystify the incredibly fascinating architecture of the internal combustion engine. Look, if you've ever stared at a car engine and just seen a massive, intimidating block of metal and wires, you are definitely not alone. But today, we're going to break it all down. We're going to look at the elegant mechanics of motion that make everyday travel possible.
And what's truly fascinating here is this simple number, 20. Just 20 specific mechanical components are literally all that stand between a parked car and a machine flying down the highway. When you strip away all the fancy accessories and the modern computer sensors, the core mechanical heart of this system relies on just a couple of handfuls of essential parts working together. It's a brilliant reminder that underlying even the most complex machines is often a surprisingly simple foundational architecture.
So, what are we actually looking at? Let's clearly define our core subject. At its absolute most basic level, an internal combustion engine is a marvel of engineering designed specifically to turn pressurized gas into driving rotational force. That is literally its entire reason for being. It takes a chemical reaction, captures the resulting pressure, and translates that chaotic energy into a smooth, spinning motion that can actually turn your wheels.
All right, let's dive into this blueprint and map out our journey. We'll start with the anatomy of the engine, then look at the static foundation, move right into the dynamic movers, explore timing and fluids, and finally, bring it all together in the power of motion. Kicking things off with Part 1, Anatomy of the Engine, the machine's blueprint.
If you want to truly wrap your head around the combustion engine, don't just think of it as a machine, think of it biologically. We can treat the static elements of the engine as the skeleton, the bones holding the whole thing together. The dynamic, moving parts, those are the muscles doing the heavy lifting and creating force. And the fluids and timing mechanisms act exactly like the circulatory and nervous systems, telling the muscles when to move and keeping the body from overheating.
Moving right into Part 2, the static foundation, our skeleton. So, the bones of our operation are made up of vital static elements, specifically the cylinder block and the cylinder head. These are the heavy, anchored components of the engine. They aren't meant to spin or pump or rotate at all. They are the solid bedrock upon which the rest of the entire mechanical system relies.
And these rigid, immovable components exist to serve a singular, absolutely critical purpose, securely housing the intense, explosive dynamic parts of the engine. I mean, think about the sheer violence of what's happening inside there. We are talking about controlled explosions happening thousands of times a minute. The cylinder block and head have to be incredibly robust to contain that immense gas pressure safely. They essentially act as an impenetrable fortress for the volatility inside. It's this beautiful contrast. You've got the unmoving, protective nature of the static skeleton, the rigid cylinder block and head providing that unwavering housing. And that perfectly counterbalances the pistons and crankshaft, which are aggressively creating that intense movement on the other side. It's a perfect architectural partnership of stillness and motion.
Which brings us to Part 3, the dynamic movers, the literal muscles.
Working in absolute tandem, the piston and the crankshaft are the specific dynamic parts that perform the physical labor inside the cylinder block. If the block is the fortress, well, the pistons and the crankshaft are the workers inside, toiling away. They are the components that actually harness the energy of those explosions.
And what's truly fascinating is the micro-story of transformation happening in literally a fraction of a second. First, gas pressure drastically builds up inside the housing. This intense pressure then forces the pistons to actuate, basically slamming them downward. And as those pistons plunge, they force the crankshaft to turn, creating that essential rotational force. It's a quick, three-step dance that converts unpredictable chemical expansion into a highly predictable mechanical spin.
Next up, Part 4, Timing and Fluids, the nervous and circulatory systems.
Because raw power needs control, right? The valves and manifolds act just like the nervous system, meticulously managing the complex flow of energy and air into and out of the engine. Meanwhile, the coolants act exactly like a circulatory system. They're continuously flowing through the engine block, managing the incredibly intense temperatures generated by all that friction and combustion.
The crucial takeaway here is that without these timing and fluid systems constantly regulating the internal environment, the engine could never maintain its operational efficiency. You could have the strongest cylinder block and the most massive pistons in the world, but if the valves don't open at the exact right millisecond, or if the coolant isn't absorbing the heat, the engine just stops. It seizes up completely. Efficiency is entirely dependent on this delicate balancing act.
Honestly, it's about survival.
By expertly managing temperature and energy flow, these systems literally preserve the structural integrity of the very vehicle you rely on every single day. The heat generated inside those static blocks is enough to warp and melt solid metal if left unchecked. The timing and fluid systems are the unsung heroes, making absolutely sure the engine doesn't destroy itself from the inside out.
And finally, Part 5, the power of motion, perfect harmony. It takes every single one of those 20 specific components we've discussed working in flawless tandem to make a car move. It's not just the static block sitting there, or the dynamic pistons firing, or the regulating valves doing their thing. It is the synchronized integration of every single part: the skeleton, the muscles, the nervous system, and the circulatory system, all communicating and reacting in real time at thousands of revolutions per minute.
The source material perfectly summarizes the ultimate triumph of this blueprint with one simple phrase: to convert gas pressure into rotational force. That is the absolute magic trick of modern transportation. It's a complete mechanical harmony designed to capture aggressive, chaotic, explosive gas pressure and completely tame it. It channels that wild energy right through those 20 components, completely transforming it into smooth, usable rotational force that propels us forward.
It kind of makes you appreciate the engineering all around us a bit differently, doesn't it? As we wrap up this explainer, I'll leave you with this thought to ponder. The next time you turn your key or press that start button, and wake up the incredible, breathing machine sitting right in your driveway. With just 20 core parts working in such explosive harmony, is the combustion engine humanity's greatest mechanical symphony? Thank you for exploring the mechanics of motion with me today, and keep looking for the hidden structures in the everyday things around you.